It's a cable.
Which cable?
It's a right
angle cable. Okay. Yeah, I'll show this on the overhead actually.
Okay.
Because it's
yeah, there's 2 photos.
Yeah, there's photos. Photos are good because it shows that it's a right angle.
Yeah. Yeah. I could do that. Okay.
Okay.
Let's do this thing.
So, okay, here we are. So, the nice thing about this cable is it's a right angle cable, and we wanted this for actually a future project we're going to do that needs to come out of the Raspberry Pi and not, like, get in the way of stuff. But it's a micro USB cable. It's a really high quality cable. We got, you see, it's actually written on the thing. It's, shoot, what is the gauge measurement? 24 wire gauge power and 28 wire gauge data. So that means it doesn't drop a lot of voltage even at high currents such as those used by microcomputers. And it's a really lovely cable, and it's 5 feet long.
That's a nice case that's in.
That's our case.
Right.
Just showing that it works with cases and stuff, like, you know, and it comes out nicely.
Okay, next up, another cable.
Yeah, this one's kind of boring. This is an S-Video cable. We had a bunch left over from Fusebox and Oozeboxes, and if you buy an Oozebox kit, you might want one of these cables. They have the 4-DIN S-Video connector. Yeah. That's it. They're like 9 feet long. They're good S-Video cables. I figured, you know, handy if you buy an Oozebox kit from us or something.
Yeah. Next up, ARM kit.
This is the LPC 810 mini starter kit. Yeah. And the actual LPC 810 is there in the corner on the left. It's kind of small, but it's like over there, or over there to the left. It's a 8-pin DIP ARM Cortex M0 Plus chip, so it's 12 megahertz. It's got like 4K of flash, 1K of RAM. It's got a built-in bootloader that's serial, which is really neat. It's got SPI I2C UART on a pin matrix, so you can change around the pins. It can run at 3 volts. It's just like a really intense 32-bit processor in an 8-DIP package, and it's kind of funny because it's like rare to see a chip this powerful actually in an 8-DIP.
Why do you think they're doing this? Because everything's surface mount. Why in the world are they doing
this? You know,
this?
there's still a big market for extremely low-cost goods that just need a small microcontroller, and they use wave soldering. Not it's hand placed. There's still some countries and some manufacturers where it's actually less expensive for them to do hand placement than to invest in.
So would this be for like developing countries? They would still maybe have through hole because it's more people labor versus machine labor.
Yeah, there are situations in which it's less expensive. It's not because they love hobbyists. I really don't think so. There is still this market. You know, I still open up consumer goods, and I do see a lot of through hole parts. Like I still do. Yeah. Especially capacitors, because they are less expensive. Through hole capacitors are less expensive, and some chips are too. So this is 60 cents. And K-Town really liked this chip, and so he's like, let's do a little mini kit. So we include some LEDs, 2 resistors, 2 buttons, 2 caps, a 3-volt regulator, and this cable that you can't really see the whole thing.
Is this a powerful chip? I mean,
it's fairly powerful. It's a 32-bit processor.
Yeah.
And you can like rearrange all the pins, and it runs at 12 megahertz on 3 volts. Yeah. And it's a Cortex M0.
It's like the little AT Tiny chips are fun too.
It's similar. Yeah. Those are 8-bit. This is similar. It doesn't have as much flash. But it also has like a built-in I2C, which is like the AT and built-in UART and built-in SPI.
And what do you use to program these things?
You can use the cable.
Yeah. Oh, I mean on the software side.
K-Town wrote a tutorial on how to use GCC.
So you can use open source stuff?
Yeah, it's all open source, and he even wrote a really big open source library for the LPC 810 that like blinking LEDs and they do some basic stuff to get started, like reading a button and stuff like that. So there's a tutorial learning system which we released on Friday that also shows you how to like use this cable and basically use open source software to get started with this chip. There's some people who just really like ARM cores. If you like ARM cores, the AT1085 is a really fun, cool chip. It has a little bit more flash, but and it might be a little bit more lower power because it's only 8-bit. Yeah. And it's lower speeds, but this one has a built-in bootloader. That's cool. It has I2C. That's cool.
And if you're using, just program in C? Like, what do you use?
Yeah, you use C.
Okay. That's cool.
Yeah, just use ARM GCC.
Huh. So you could probably make some like little low-cost little ARM projects with this thing, right?
Yeah.
Yeah.
I mean, like if you want the 32-bit like power, I mean, it probably has like full multiply and stuff in it.
Yeah.
I mean, it's a Cortex M0 Plus core. It's a low power.
Faster than my old Mac.
Yeah.
Jeez.
Well,
Cool.
it doesn't have as many pins.
Yeah.
But it's a really interesting chip, and I was like, yeah, this is kind of cool. It's so weird. It's like an 8-bit pin dip, but you can do a lot, so check it out.
Yeah. Get them before ARM realizes what they're doing, I guess. All right.
I'd like to see what products this would be used in, but there might be some products that
Okay.
used for.
Next up, what are these, Lady Ada?
These are some more SMT breakouts. We had them in 44-pin. We had them in 32-pin. We have them in 28-pin, and now we have them in 48-pin. And 48-pin is actually let's go darker so it doesn't reflect as much. The 48-pin, and it's very fine pitch, and it's QFN on this side, and there's a hole in the middle because there's the center pad is sometimes connected to ground, or sometimes it's a heat sink, but you can't actually, you'd use vias. And so we just brought it out to the other side, and then you can, connect a wire to it or something. And on this side, it's a QFP, and it's a 48 pin QFP, 48 pin QFN, and you get 3 of them.
Yeah, the feedback that we've heard is up until recently, no, Adafruit we didn't make these, and people would have to buy these from other places, and they were so expensive.
They are usually really expensive, which I don't understand why. Like it should be.
Yeah.
Like
So how much do we charge for these?
We charge $6 for a set of 3.
$6 for a set of 3. Someone had posted up and they said, I had to pay like $20 for one.
Yeah, they can be really expensive, especially if you buy them from DigiKey. I don't completely understand why, but the DigiKey ones are like, the surfboards are really expensive.
Yeah.
But these are nice, and you can do you get twice the value because there's a QFN and QFP, so you can use either one.
This is one of the things that you showed me. So you had your folder of projects all the way back from school, and you're like, one day I'm going to go and make low-cost versions of these because it was so expensive.
When I was at MIT, we used to buy surfboards from DigiKey, and they were so expensive that like one day I just got really pissed off. And in Eagle, I just made like all the breakouts, and this was in 2005.
Yeah.
And I still have that folder, and so all these SMT breakouts are actually the same. Basically the same files from 2005.
Yeah.
And they were like an Eagle 4, like 3, like Eagle 3 or Eagle
Still opened.
It's still open, yeah. And I was like, this is great. So
yeah.
I didn't actually do a 48 pin. I think I did a 44 and a 32, but because I couldn't solder these by hand back then, but now I can.
Yeah.
More skill.
All right, next up, we've got some chips and some LEDs. I don't know if you want to show both of these at the same time.
Yeah, sure.
All right.
But then these photos they can show it much clearer.
Yeah.
These are both of the same family. These are the NeoPixel LEDs. So we have like the strips and like the fluoropixels, and we have the SMT chip version, the SOIC chip, and you also have the LEDs that have the chip embedded inside of them. So they're the same protocol, and they do basically the same thing, but one has an LED with the chip inside of it, and one is just the chip.
Yeah.
So actually, it's actually a little easier to just talk about it. So the first one is...
Oh, this one.
This.
You're going to go this one.
The first one is, this is the WS2811 LED driver chip. So it can drive 3 LEDs. Usually it's just an RGB LED. It's an 8 SOP, 8 SOIC, so it's pretty easy to solder. You can use our breakout boards, or you can make your own breakout board. We have it in our Eagle library. It's 1-pin chainable, so you can chain these together. They are powered off of like 5 volts or so, like 5, 6, 7 volts. They can drive 1 RGB LED. They have a built-in clock, and you can use any microcontroller that can do like 8 megahertz or faster precision timing. Can't be used by something like a Raspberry Pi because it's running a Linux. It's not real time, but an Arduino works really great. We have Arduino code. Mbed probably works. PIC would also work. AVR. Any of these like real time chips will work. You probably could get it working in Linux, but you'd have to write a driver, and I don't really feel like writing a driver. So if somebody does, that'd be awesome. And then, so that's if you want to use your own LED. Like you're like, oh, I have like a big diffuse LED, and I want to use it and make my own like smart pixels. But if you want to go easier, actually for the same price, you can get the 5050 LED NeoPixel, and these are little 5mm or 5mm RGB LEDs with 6 pads on either side. And the chip, you can actually see it. It's the little black square in the middle there, the little rectangle with the gold threads coming off of it. And that's the same chip as before, except it's actually embedded in the LED. And similarly, you power it with 5 volts, and you have data in, data out. You can chain them. We sell these on strips. We use them in the floor pixels. They're really handy if people want to make their own stuff. Using these pixels, you can put a bunch of them on a board, or maybe a project. Yeah. It's like the easiest way to add an RGB LED. So you get 10 of each. Actually, they actually are the same price, which is kind of funny. Like buying the chips from the factory, they're the same price. So you get 10 for $5, so it's 50 cents each. So it's like the same price as a normal LED. Yeah. But you have the controller chip inside of them, and then our Eagle library has both of these. And we used both the Eagle. They're both tested. We've used them in a bunch of projects, so it's really easy. You just pick these up and you just lay them on your board, and you can solder these pretty easily as well. Pads are fairly big. Okay.
Next up, speaking of blinky LEDs, look at this.
It is blinky.
Yeah. Okay. You want to do a demo?
I am going to do a demo, but I have to plug it in.
Plug it in, okay. So this is the NeoPixel.
So this is the, no, it's blinky. This is the NeoPixel strip that's 30 LEDs per meter. So we are now carrying both the 60 LED per meter and 30, so 30 is less dense, but it loses less power, and it's a lot less expensive. So this is like $16 a meter, which is pretty cheap. I'm going to go to the big yeah, go to the big screen. So this is, you can actually kind of see each LED separately in the strip. So it's about 30 LEDs per meter, digitally controlled. I have an Arduino just controlling it. It's less expensive than the 6 LED per meter, and it uses less power. And if you don't need the density, then this strip is really great. And yeah, you can control every LED separately, which is quite nice. You can accidentally unplug it. Oops. There you go. Holding up. And yeah, it's super bright. And it uses those LEDs I just showed you, but they're already on a strip ready to go. So you can just cut this, solder it. It's in a weather-resistant rubber coating.
Could you put this in the scarf if you wanted to?
You could, but it's a little, it's rubbery. It wouldn't be as soft. So this uses thread, so it's perfectly soft. It doesn't have any stiffness to it.
Okay. And then we do have a couple other photos. For folks
so this is the back, just showing what the back looks like, and this is the front. Yeah. So there's an LED, and you see there's no chip. Because the chip is inside, the driver chip, because the chip is inside of the LED itself.
How many pins do you need to drive the whole?
1 pin.
1 pin.
And our library.
Yeah. Okay. And then last but not least, kind of the star of the show this week, this board is shipping. This is a big deal.
Yay!
For the folks who know, they know what this is, and they know it's a big deal. But for the folks who don't know, you can explain it.
This is the VLSI VS1053 codec chip. It's actually funny, I used this chip for the Minty, I think I used this chip for the Minty MP3, which is a project I designed in 2005. So there's a lot of like 2005-esque projects I'm finally getting out. So this is a board that I made something very similar. Maybe I'll pull it out one day. It's got the codec chip on the right there, and then it's got level shifters, and it's got a MicroSD socket. So this is kind of everything you need. Just add a microcontroller, and you've got a music player, MP3 player. It's an MP3 decoding chip. It can do MP3, wave, both the compressed and uncompressed, Ogg Vorbis, AAC, WMA, and then like FLAC if you have a software plug-in. Like you can basically do like nearly every popular music encoding. And it can actually also encode audio. So it can decode audio, and it can also encode Ogg Vorbis, which I wrote a whole bunch of code for it. So you can record it and actually have example code. I don't have the demo for that, but I do have example code for it. You got an electret mic and like 2 or 3 little passives around it, and you can actually use it as a recording module as well. And what this chip does, it's actually a DSP, this thing that I'm not really into. But it does all the stuff on the chip. So decoding MP3 actually requires a fair bit of processor capability. You actually need like a fairly good processor to do it. An Arduino or Basic Stamp or even an Mbed doesn't have that ability to decode, or even I don't even think a propeller could do it.
Yeah,
you actually need quite a bit of horsepower and ability to do mathematical calculations. This chip is really nice. You just kind of stream the data to it. You just open up an MP3 file and you send it the data, and it will automatically decode it for you and do all the decoding. So it'll do that with Ogg Vorbis or Wave or MP3 or any of these formats. And so this is kind of handy if you want to make like a sampler or a project that plays audio, or like, you know, you press a button and it makes a sound, an effects box.
Yeah.
So this is a really nice chip, and I kind of broke out all the extras, and we have example code for it. It has 8 GPIO, so even though it uses a lot of pins to control it, you do need like 6 pins to control it. You get 8 pins, you know, free, and we have example code for like reading and writing, so you can use those pins for buttons, for example. It's 5-volt compliant, so that you can use it safely with a microcontroller like an Arduino that uses 5-volt logic without any problems. It's got onboard regulators. It comes with all sorts of cool stuff like a headphone jack, some header. It's just it's all good fun.
Yeah. Can you use it with speakers?
Yes, I will even show it with speakers. Let me.
There must be a demo coming up soon.
There's a demo coming up, so let me actually.
Can we go to the overhead?
Yeah.
Okay.
Let me bring this up. Unfortunately, the compressor's going off. Whoa, lights in the wrong place. So this is the okay. So this is the MP3 decoding board. This is an Arduino, and I'm just powering it from the wall. And I have a microSD card in here with one of the free Ogg Vorbis tracks that is used to demo Ogg Vorbis. And I connected it through this headphone jack, which I have externally. And we did that on purpose. I didn't want to put a headphone jack on it in case you wanted to wire up a headphone jack elsewhere. And I can turn it up. So these are basically just like this power speakers we have in our store. You can also use it with, we have an amplifier board that works really well. We have example code for all this stuff, so it's really plug and play. It's quite easy to get going with this board.
I saw other boards out there, and they just, you know, they said, oh, the chip does recording, but there was no one wrote any software, so no one ever.
I'm the only one who wrote the code.
There was no examples. Yeah, no.
Because I have to build the tester, and how am I going to test if the boards can record? So each time we test the board, it records audio through the microphone.
Yeah.
So you can get the microphone and line in. So
does it delete the audio afterwards, or do we leave it on there? Like when we test the recording?
every time it overwrites it.
Yeah. Because that'd be funny, little sights and sounds or sounds of Adafruit. You'd probably hear it beeping that the test passed, right?
Yeah, it beeps when the test passed. No, the SD card would fill up too fast. But yeah, so it's really easy to use. You can use to put audio on it. You just take the SD card and you put it into your computer, just like any other SD card.
There's a lot of questions about this, so we're gonna end new products. This is over.
End.
The new products is over. Thank you, everyone.